Okay, so 10.7, we're going to start dealing with our imaginary numbers, the imaginary unit and complex numbers, which sounds bad. Most of it's pretty easy. It's either directly based on what we've done already or very similar to things we've done in the past. So there's two important things to remember for 10.7. If you remember these two things, you'll be pretty set. The square root of -1 is equal to the imaginary unit in math, which we denote with a lowercase I. So we have a way to represent negative square roots. So no longer will you ever write not a real answer. We know they're not real answers, but we're going to write them in terms of the imaginary unit. So if we have a square root of a negative number, all that means is we're going to have an I in the answer, the imaginary unit. Now if you think back to what we did in 10.6, there's one other fact we need, and we can get there just from this definition. This is your definition of the imaginary unit. How do I get rid of a square root when it's in an equation? Square it. That's what we did in 10.6. That's what was on your drill today. You said, okay, if I don't want the square root, I just have to square it. Well, what happens to the side that has the square root and the squared? Yeah, they cancel each other. So that means that our other fact is that -1 equals I squared. And that's how it's derived, is we're just squaring both sides of that. So these are the two really big important things in 10.7. Those are the two things to remember. If you get I squared, we replace it with -1 because we'd rather have something real than imaginary. And if you get the square root of -1, you replace it with an I. Now the only times you get I's in your problems are if you have a square root. Doesn't matter for cube roots, fourth roots. This is only for square roots, and you have a negative sign underneath. So we want to express each number in terms of I and simplify if possible. So when you see a negative under a square root, that's how you know you're going to get your imaginary unit. And the way we get that is you start by taking the negative sign out. So we're going to break off -1 times and then just turn that radicand to be positive. So -1 times positive 16 is by -16. Well, what's the square root of 16? 4. So we know that this will come out as a 4. And what did we just say the square root of -1 is? I. So the answer, and we usually put the number first, the answer is 4I. So it looks like your regular answer for the square root of 16. It's just got the imaginary unit on it because there was a negative under the square root. So for B, the square root of -37, whenever you see a square root, remember, not cube roots, just square roots, square root of a negative number, separate out the -1 and then make your radicand positive. Now, question, can I do anything with that 37? So we're still looking at the 37 as we used to. So we're going to try to break down the 37 using our perfect squares. So do any of my perfect squares evenly divide into 37? No. Okay, but if I'm looking at this product, half of this is what we're going to consider perfect now. Because I know what the square root of -1 is. What's the square root of -1? I. So I'm going to get an I out front, and then what's left over is the square root of 37. But I can't do anything with the 37 because it doesn't evenly divide by one of my squares. So whenever you see a square root of a negative number, you could start by just putting I and then the square root of the positive radicand. Because when you take that I out, what you're really doing is you're taking out the square root of -1. Anna? The negative's gone. That's the I is getting the negative sign out. So like if I look at C, I see this on a test. Is that going to be an imaginary answer or a real answer? Is there a square root underneath the radical? sorry, a negative underneath the radical, underneath the square root. So a negative underneath the square root, that's how we know we're going to get the I. So I'm going to start by breaking this up. I'm going to make a negative 1 times 50. Only do this for square roots. So you could even, right from the get-go, say this is I times the square root of a positive 50. That's what the negative sign underneath does. It puts an I out front and makes the radicand positive. But then we've got to look at the real part as well. So the square root of 50. Is there anything I can do to simplify the square root of 50? 25 times 2. So I've still got the I out front, and then the 50 I'm just going to break up as we would have done before. So what number is coming out front with the I? 5. So it's just going to be 5I square root of 2. So it's almost exactly how we would have simplified the square root of 50. It's just got the I in it, the imaginary unit, because it was a negative underneath. It's the only difference. How about D? Is D going to be an imaginary answer or a real answer? Got 2 votes for real. Anybody else? It is real. Why is this one real? Yeah, negatives outside. So make sure you're paying attention to where the negative signs are. It makes a big difference. This one is real because the negative's outside. The only time you get I is if you have a square root and the negative sign is underneath part of the radicand. Everything else for us is still real, except for maybe a 4th root with a negative. So the negative sign out front just means it's negative, and then you break it up the same way we broke up 50 for C. So the answer is just negative 5 square root of 2. We don't have an I because the negative was out front. The only time you get I is if the negative is part of the radicand for a square root. Cube roots can be negative and have real answers. Not a problem. So big difference between C and D. The only thing we see different in the problem is where that negative sign is. Now E is just an example like they put in your homework to get you into the idea of a complex number, which has half that's real and half that's imaginary. And we're going to do some work with complex numbers today. They're very easy to work with because the imaginary unit works like a variable. So 6, we have to leave the 6 alone, but I'm going to do plus the square root of negative 4. Any guesses as to what the square root of negative 4 is going to be? I. So it's just the square root with an I after it because it was negative. So if you need to break it up, and I'm okay with you just going right to the I, especially with perfect squares. It's just the square root but with an I on it. So the square root of negative 1 times 4, both of those are what we're going to consider perfect. It's just 2I. So the answer is 6 plus 2I. Now think of that I when it comes to adding, subtracting like a variable. And we're going to get to this today. If I have an I on one term, I can add it to any other term that has an I, just like with an x. So like 2x plus 3x, we can add those together. 2I plus 3I, we could add those together. But because this 6 doesn't have an I, they're not like terms. So we'll get really into that. Your homework, for some reason, puts it in this first section. But we'll talk about those rules in a little bit. F, do you think it's going to be real or imaginary?
Real.
2 votes for real. Both? No, one or the other. Real or imaginary?
Imaginary.
Rob says imaginary. What do you think, Sarah? Imaginary. Sheena, what do you think? We're 50-50 now.
Yes, the same thing.
Same thing as who? Imaginary? It is imaginary. If you've got a negative sign under a square root, it's going to be imaginary. The negative sign out front can't somehow like get into that square root. It's just going to be the negative sign that carries through. So negatives out front always carry through. It's this guy right here that tells us we're going to have an imaginary answer. So the negative sign out front just comes down. And then I'm looking at negative 1 times positive 32. That's how we can get that imaginary unit out front. And then just like before, we've got to worry about that 32, trying to break up that 32 using my list of perfect squares. 16 and 2. So it's going to be negative 1, but then that 32 we could split up as 16 times 2. So of those three factors, what am I going to get to come out front? 4i. So the negative 1 is going to give me the imaginary unit. The square root of 16 is going to give me 4. Left over is the square root of 2. And this negative sign out front literally just carries down every step. Questions? Devin. No, this is a negative 1 out front, but it's just the number negative 1. It's not the square root of negative 1. That's the difference. You have to have the square root around a negative 1 to get the I. Just the number negative 1 is not going to give us that. It's going to be the square root. It's a good question, though. Any other questions? I must have an exciting class next door. All right, I want you to try. All right, so how'd you break up the 72? How'd you break? There we go. How do we break up the negative 72? Negative 1. This would have been the quickest way. Again, the only difference from the square root of positive 72 is that negative 1. And what's the square root of negative 1 give us? I. So just the only difference is you're going to have an I in your answer. So we're looking at 6I square root of 2. Very, very, very similar. Only difference is you have an I. And when do you get the I? There's only one time you get an I in your answer. Negative under a square root. Under a square root. The other thing I want to point out is there's no such thing as the square root of I. Sometimes you're thinking ahead, you're like, okay, that negative is going to give me an I, and I see a lot of square roots of I. What gives you I on the outside is the square root of negative 1. So don't try to skip ahead and put an I under a square root. There's no such thing as the square root of I. So any questions? There's only one more topic that actually uses this idea of the square roots of the imaginary, and then we're into complex numbers, which, despite their name, are very easy. So the one thing that's kind of tricky about these is that whenever you're multiplying and dividing and you have imaginary roots, there's no product rule. So if these were real, all we do is multiply their radicands together and then simplify. But when you want to find a product and you see that any of your roots are imaginary, there is no product rule. Can't stress this enough. Anyone who misses today and doesn't go back over it will get this wrong on their test. 100% guaranteed. There's no product rule. So what we used to do is just multiply negative 4 times 25 is 100. We called it a day. We simplified the square root of 100. We got 10. What you need to do, and it's in number 1 here. It's in bold. I even wrote must do after it. Very, very important. When you're asked to find the product and you're dealing with imaginary square roots, there is no product rule. The first thing to do is to just rewrite them individually in terms of I. So if you're multiplying and they are imaginary, rewrite them first. Simplify them first. So what's the square root of negative 4? 2i. So you just take the square root of 4 and you put the I on the end. It comes from that negative 1 times 4, so this is 2I. The perfects are easy. You just take the regular square root and put an I on the end. So what's the square root of negative 25? 5I. So this is 2I times 5I. Okay, let me put the middle step in there. Now it works like I works like an X. That's another thing that makes it kind of nice and familiar. So like if I had 2X times 5X, what would I get? So if you'd get 10x squared. So when I have I times I, just like an x, 10I squared. Works just like a variable. That's why it's nice. But we had a fact on the front. I'd much rather have real numbers than imaginary numbers. So there were two things I said you had to remember. The first was that the square root of negative 1 is I, and the other one is I squared equals negative 1. If you ever get an I squared in an answer, we've got to replace it with its real equivalent. I squared equals negative 1. So we're going to take this I squared here, and we're going to replace it. So this is 10 times negative 1. So wherever we get an I squared in an answer, we can replace it with a negative 1. So the answer, negative 10. Now, if you do this incorrectly, here, I'll put this with the no product rule. In red, don't do this. This is the wrong answer. People who aren't here, who don't watch this, are going to say, okay, product rule, multiply those together, I get the square root of 100, which is 10. The answer is not 10. The answer is negative 10. And you're not going to get that unless you simplify your radicals first. Really, just all you have to do is take the imaginary unit out, and then what's left is real, and you can apply the product rule to it. So if we look at B, how do I know I've got to go through this process? I'm multiplying, and there's negatives underneath my square roots. That means there's no product rule. So let's start by just getting the imaginary units out of those square roots. Once the imaginary units are out, we can use our product rule because what's left over is real. So let's start with the square root of negative 7. So I would start by taking the square root of 1 times 7. And when I see a square root of negative 1, that's going to come out front as what? I. So this is I square root of 7. I wouldn't even worry about trying to simplify the individual square roots yet until we put them together. So 7 isn't going to simplify, but I wouldn't even worry about that at this point in a problem, which will come in our next example. So how else might I rewrite the square root of negative 3? Square root of negative 3. I, and then the square root of 3. And once you get that imaginary unit out front, these are both real. Square root of 7 and square root of 3, which means the product rule is back. So all you got to do is take the I out, and then you can use your product rule, because these two square roots are now real. So this is I times the square root of 7 times I times the square root of 3. So think back to 10.5 where we were multiplying. What do you think I can multiply together in this problem? The i's. Yep, I times I. The things out front, just like in 10.5. They were numbers before, but it's still stuff out front. I times I is I squared. How about my square root? Square root of 7 times the square root of 3. Square root of 21. Now the reason I could use my product rule is because those are real now. I can't do it from the get-go because they're imaginary. All I've got to do is get those i's out front, product rule's back for the rest of the problem. But that's the thing you have to remember in these problems to get them correct. Am I ready to box my answer, you think? What do I not like that's sitting there? I squared. It's real. Put it back to a real number, which is -1, or you could really write this answer just as negative square root of 21. Either or. And I should say, you would try to simplify your 21. It doesn't. I jumped ahead a little bit there, but 21 doesn't divide by 4, 9, or 16, so we know we can't do anything with the 21. Yeah.
But this doesn't say simplify.
You always have to simplify. It's like fractions. Okay. After you learned how to simplify fractions, every fraction you left as a final answer was simplified, and the general directions on the test say to simplify everything. No. No. Your only options would be 16, 9, or 4. None of those go into 21. So C, want to multiply that. Now, what I suggest for these problems is that you start by just taking your imaginary units out so you can apply the product rule to the rest of the problem. So if I just want to get rid of the imaginary unit, get the imaginary unit out, how might I rewrite the square root of -8? I square root of 8. When you see a square root of a negative, it just means there's going to be an I out front, and then the radicand is positive. So I could start by rewriting the square root of -8 as I times the square root of 8. And I wouldn't break up the 8 yet. It's going to create a little bit of extra work, actually, if you do it at this point. So in terms of the imaginary unit, how might I rewrite the square root of -5? I square root of 5. And now we can use that product rule. And since we're back to real roots, I suggest you follow our product rule like we had in 10.3, where you multiply once and simplify once. Instead of trying to simplify, simplify, multiply, maybe you have to simplify again. Multiply once, simplify once. So what can I multiply together in this problem? Yeah, we're going to add the I times I because there's the stuff out front. And then how about the square root of 8 times the square root of 5? Square root of 40. So you keep the square root, and you just multiply the radicands. Now we got to clean that up. What do you want to do, Napoleon? Yeah, that 40 can be broken up this time. Is the square root of 4 times 10. How about the I squared? -1. So I have the square root of 4 times 10. What number is going to come out front from that? 2. You got to take the square root of 4. So, oh, sorry. The 4 is going to come out front as 2. I get what you're saying. And what's going to happen with that -1 and that 2 that are both out front now? Multiply them. So our answer is going to be -2 times the square root of 10. Anna. Yes, you can, but the only thing is occasionally you could break down, say, both of these, but then when you multiply the square roots together, you'd have to break it down again. It didn't happen in this problem, but it works. It might just create extra work for you in the future. So it's okay to do. It's absolutely okay to do. Just make sure that every step of the way you make sure that final square root is simplified. Absolutely. In this problem, it would have worked out about the same amount of work. Questions? Go ahead and try D. Try multiplying in D. So this one was a little bit different, but I didn't catch too many of you. So what do I have to take an I out of in this problem? Yeah, just the square root of 3 right here. The 7 doesn't have a negative underneath, so I'm not going to get an I. I'm just going to get I times the square root of 3 times the square root of 7. And now that everything's real, we can use our product rule. We've just got to take those i's out first. So what can I multiply together here? Yeah, the square root of 3 times the square root of 7, which it's good. I'm seeing everyone put their square roots around these answers. I bring down the I, and then the last decision is always, do I have anything else I can replace? Do I have anything else I can simplify? No, so I don't have I squared this time because only one of those square roots gave me an I. So I'm going to have an imaginary answer. I'm just going to have the I in my answer, which is fine. And then for the 21, if I look at my list, we already looked at our list a little bit. For 21, none of my square roots evenly divide it. So I'm done. Questions? I told you, the imaginary stuff is just like one little add-on to everything we've already done. But just remember, until you get the i's outside, there is no product rule. You've got to get the I out first. So the rest of what we're going to do in 10.7 today is going to be adding, subtracting, and multiplying imaginary numbers. They work just like X. So this is like the first and second day of class all over again. The only thing we're going to be on the lookout for is I squared equals -1, which actually we won't get in this first, in adding and subtracting, only when we multiply. The other key to these problems is when we read our directions, it says write the result in the form A plus BI. You always write the real term first, the imaginary term second. So even if they end in the wrong order, for your final answer, you've just got to flip them around. Real first, imaginary second. That is the form of a complex number. But they work just like X's. So if I have 2i and I add 5i, I get 7i. Just like when you add x's, you keep the x. When you're adding, you keep. When you multiply is when you bump it up. When you're adding, you keep whatever makes them like. If they both have an I, you keep the I. You just add the coefficients. So if I have -4i minus 6i, -10i. So you're combining them like you would a variable. It's not a variable, but that's how they combine. You add or subtract the coefficients, you just keep the I. Now, when you see problems like this and you see parentheses, some people, and even though I'm warning you now, some people on your test are going to multiply those. What do I want to do with those two complex numbers? Add them. There's an addition sign right there. The directions, add or subtract. So make sure you don't waste your test time foiling that. It's just adding. The parentheses are just showing that this is one complex number, real half, imaginary half. This is one complex number, real half, imaginary half. However, think back to the first day of class. When we had addition between polynomials, did we have anything special we had to do? Not for addition. No, so this is really just 5 plus 2i plus 4 minus 3i. Yeah, it's just like the first day of class. Find your like terms, put the real ones first, the imaginary ones second. So I can combine my real terms. 5 plus 4 is 9. And I can combine my imaginary terms. 2i minus 3i minus I. Or if you need your ones there, you could put -1i. But we usually would put just minus I. Now D is subtraction. Again, notice there's a sign before the parentheses. What did I have to do first day of class if there was a negative in front of parentheses? Distribute it. So it's, again, stuff we've done before. Here we go, -1. So it's going to be 6i minus 2 plus I. what do you think should come first in my answer? The negative 2. So the real always comes first. The real's always first, which is negative 2. And then 6i plus I gives me how many i's? 7i. If you need, that's 1i on the end. 6 plus 1 is 7i. So go ahead and try E. See if you can subtract those two. Let's go first. The only ones you really have to be careful on are the subtraction problems. Addition problems, just like the first day, you take them out of the parentheses, you combine your like terms. Don't make these problems multiplication. Word of warning. And people are still going to do it. And they're going to take forever on their test on this problem when it should be a simple distribute your negative to change the signs. And then combine your like terms. Real always come first. Imaginary come second. Oops. Minus. And if you need, you can always put the 1 in front of that I. Questions? All right, I know we're doing a lot today. We've got one more topic, which looks like the second day of class. So that's a nice thing. You hear complex number, you think that's going to be really bad. They're just like x's. This is the one where we really, 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 really need to be on lookout for the I squared. So I'm multiplying now. Find each product. Don't forget to write your answer in the form A plus BI. So negative 5i times 3i. Pretend they were x's. Negative 15i squared. And I get an I squared since they were both throwing an I in. And we're multiplying. When you add, you just keep the I. But when you multiply, you're going to account for all of them. Bump that up. Am I ready to box that answer in? What don't I like? I squared. Shouldn't see I squared in any final answers. I can replace I squared with negative 1. They are equal. So my answer is negative 15 times negative 1, positive 15. So when you multiply two complex numbers together, you can get a real answer. Two things that are multiplying, both complex, final answer, real. What do you think I'm going to have to do in B? Distribute. I'm going to have to distribute that negative 2i. So negative 2i times positive 6 is negative 12i. And then negative 2i times negative 2i, positive 4i squared. Since they both had I, make sure you get I squared there. And what can I change out in this answer? What can I change out in this answer? It's going to be 4 times negative 1. So 4 times, we're going to replace that I squared with a negative 1. So I have negative 12i minus 4. Am I ready to box my answer? I have a yes, I have a no. Got to flip it. Make sure when you change it, you take the signs, which in this case you don't actually see since they're both negative. But the negative 4 is actually got to go first. And the negative 12i has to come second because our directions say write in the form A plus BI. That will always be part of your directions for these complex numbers to make sure that you get the real first and the imaginary second. So even though it didn't end that way initially, to write it in the form of a complex number, we've got to switch that around. C C, I have a complex number times a complex number. What do you think's going to happen there? We're going to FOIL that. This is why I said don't turn addition problems into FOIL problems, because then you're just making more work for yourself. So first we have 3 times 6 is 18. 3 times I, 3I. Negative 4I times 6, negative 24I, and then negative 4I times I, negative 4I squared. The first thing I would personally do is take all your I squareds and replace them. So this last term has an I squared, and what can I replace I squared with? Negative 1. So it's negative 4 times negative 1. So the last term is actually positive 4. Whenever you have an I squared, it just changes the sign and loses the I squared. So we have 18 plus 3I minus 24I plus 4. Now I'm looking for like terms. Which ones do I want to combine first? The 18 and the 4, the reals. Real comes first. Always real first. That's in your directions, A plus BI. So we're looking at 22 plus, I have 3I minus 24I. Oop, I don't know why I put. When you're adding, it's just I. Only when you multiply do you get the I squared. When you add in, you just keep it. Like x's, you keep the x. When you multiply is when you bump them up. And for D, we're actually going to save E till next time. E is actually the segue into our last question. For D, if I have a complex number squared, that's it twice. Multiply it by itself. And then you FOIL it. So don't distribute the squared, write it twice, and then FOIL it. So we're going to get 1, I'm going to do this one a little bit more quickly because we're at the end. 1 minus 2I minus 2I plus 4I squared. And again, whenever you find I squared in your answer, first thing, let's go ahead and replace that with a negative 1. So it's just going to switch the sign on the 4. Turns negative 4. So 1 minus 2I minus 2I minus 4. What should I combine first? Negative 4 and 1. Combine those reals first. Negative 3. How about negative 2I minus 2I? Negative 4I. Good. They don't cancel because they have the same sign. And we are purposely going to do E next time. If you've already done it, it's okay. But we're going to start next time with E.